Hey guys, welcome back. So my bench today, I've got a Silverface Champ. I believe it's 75, but I'm going to be double checking that. So we're going to be doing a couple things. We're going to fix it up and return it to stock because somebody had previously installed a couple mods. They added a whole nother gain stage. They drilled a new hole, added the new preamp tube socket. They also added a master volume control and this like presence mid control type thing. So my customer and I agreed that we would like to return the amp to stock, fix it up. It is actually original parts. Whoever modded the amp used, the same bypass caps, same resistors and everything that they could. So we'll be, restoring the amp. The filter caps original, we'll be replacing that. And then we'll also be putting the amp into a brand new cabinet with a new speaker. The front panel hasn't been physically modified, but the volume control has now become the master volume. And on the back here, you'll see that the back panel has been modified and two controls have been added. This control becomes the gain, and this control is like the mid-presence type thing. Alright, so I'm going to demonstrate the amp with the mods in just so we can get an idea of what it sounds like before we return it to stock. So this is the amp with the master volume pretty much all the way up, and the gain is pretty much all the way down, just so you can get an idea of what the clean signal sounds like. I don't know if you can hear it, but it's pretty hummy. Alright, and now I'm going to crank the gain and lower the master volume. Looking at the underside of the chassis, we can see that both preamp tubes are Chinese 12AX7s. This is the tube that has been added. You can just tell it's not stock because the hole wasn't like perfectly punched, and it has been drilled over this stamp right here. The output tube, the 6v6, is a Mesa tube, so I'll probably change that to an Electro-Harmonics. And we've got the filter cap here, that's original, so I'm gonna change that for reliability. So the output transformer is stamped for 75. You can tell by this number right here that starts with 606. So it always reads 606, and then this number, the 5, is the last digit of the year that it was made. And since this is a Silverface amp, I know it wasn't 65, but it was most likely 1975. And now for the circuit. So pretty much what I'm gonna do is just unhook everything that doesn't belong or is not stock and take it out, and then I'm just going to rebuild using the original parts, except for the bypass caps probably, and just make it match the Champ schematic. Here's a slow pan of the mods for you. I got cut off while I was removing all of the modified parts. So here we are. I have now a nice blank slate to work with, and I'm just going to compare this with the layout and schematic of the Champ and get it back to stock. Okay, so the first thing I see missing are the two 68K grid stopper resistors that are supposed to be in the input circuit. Here are the two 68K grid stoppers on the schematic, and then here they are shown on the layout. Basically, the grid stopper resistors block any sort of impurities like radio frequency, oscillation, any other, types of noise that we don't want entering the first gain stage of the amp, because that would taint the guitar signal or introduce noise, which would be further amplified down the line. Alright, so now I'm going to add two 68K resistors, one each to this side, one each to that side, basically one coming from each input jack. Now what I'm going to do is remove the input jacks so I can access them better, and then I'll have to run the wires from each tip of the input jack to each corresponding grid stopper resistor. Alright, so I have the input jacks out. I'm going to be using the original wire. And now I'm going to move on and install a new 25 microfarad at 25 volt bypass cap and the affiliated 1.5K cathode bypass resistor. All right, and just to confirm, this wire goes to pin 3, which is the cathode of V1A. And before I forget, I'm going to run the wire from here to pin 2, which is the grid of V1A. And now moving on to the plate resistors, which go to pins 1 and pin 6. These are the plate resistors right here, and they're all correct. I just need to run the wires. So this junction goes to pin 1, and this junction goes to pin 6. We're missing the 0.022 coupling cap right there, which we still have. So I'm going to disconnect all this stuff and install this cap back in the circuit. Okay, moving on. So now all that we're missing from this tube is pin 8, which is another bypass cap and resistor, and then pin 7, which comes from the volume control. So right now I'm going to add the missing bypass cap and resistor, and then we'll go from there. Alright, so I added a jumper connecting this resistor to the negative end of the bypass cap. And actually, it doesn't connect directly to ground. It goes to a 47 ohm resistor to ground. The 47 ohm resistor goes right here, and then there's a 220K resistor that goes right here, with the ground connection being this center eyelet right there. I need to run the wiper of the volume pot, which is the middle lug, to pin 7 of the preamp tube, which is the grid of V1B. And I'm going to use the shielded wire to reduce noise. And basically what you do is you ground one end of the shield, the other end you do not ground. It's going to be easiest to ground the shield right here where the volume pot is already grounded. To just show you, here is the signal end of the shielded cable. It goes from the wiper to the grid of V1B, and then the shield is grounded on one side and it is grounded where the volume pot already has a ground connection. The final detail here is just hooking up this wire that goes to pin 5 of the output tube, which is the control grid, to this point right here. All right, so this amp is pretty much back to stock. I am going to replace the bypass cap for the output tube. It's important to do that because the 6v6 is cathode biased in this amp, and it's important to have those parts functioning optimally. So I'm just going to change the cap for now. I'm gonna leave the resistor because I'll probably have to adjust the resistor value in order to dial in the bias. And I will show you guys how I do that. One more thing I'm gonna do is replace this filter cap. I'll also replace the 2 voltage dropping resistors since I'm doing the filter cap. Since I'm not soldering the ground lugs to the chassis, I'm gonna run a ground wire from here to the ground lug right here. All right, so I have the filter cap can all wired up. I also removed the depth cap up here. Okay, so the output tube is cathode biased, and in order to check the bias and see how hot the tube is running, we need to take a couple of measurements. The first measurement is the plate voltage to cathode voltage. So basically we set our meter to DC volts. We put one probe on the plate, which is pin 3, and the other on the cathode, which is pin 8. And we're getting about 362.2. And then the second measurement is the voltage across the cathode resistor. And we have 25.48 volts. And then the resistor value, which is 470 ohms. So I like to use Rob Robinette's tube bias calculator. Basically what you do is over here, you choose the type of output tube. It's a 6v6 GT tube. And then you enter the plate to cathode voltage measurement, which we got 362.2 volts. And then we come over here and click calculate. Now we scroll down here to the tube dissipation using cathode resistor voltage drop. Enter number of tubes that share cathode resistor. There's just one output tube. And then the voltage across the cathode resistor is 25.48 volts. All right, so then it calculates that the plate dissipation per the tube is 132.1%, which is very high. We're ideally looking for about 75% dissipation, which is an ideal operating level for the tube where it's not running too hot and not running too cold. So we're gonna have to choke down the current a little bit in order to get a cooler plate dissipation. So to do that, we're gonna have to increase the value of the bypass resistor. So basically what I've done is removed the 470 ohm cathode resistor, and I'm clipping one end of a 560 ohm resistor to one end of the cap. And then the other end of the resistor, I will clip to the other end of the cap. And then we're going to remeasure the voltages and input them in the computer and see what we come up with. All right, so a 560 ohm resistor puts it at 114%, which is still too high. So we're gonna have to go a little bit more drastic. I'm going to put in a 1K resistor and see where that gets us. So with a 1K ohm resistor in, we still only have 82.9% dissipation. That's as high as I'm gonna go, and that's okay. The tube's probably not gonna red plate. But I just don't want to go much higher and risk, you know, altering the tone a lot. So that's where we're gonna keep it. All right, so I've installed the 1K resistor for the output tube's cathode, and that is all we gotta do. I've serviced the amp already, cleaned all the pots, jacks, switches, cleaned and tightened the tube sockets, and all that good stuff. And I'm gonna go ahead and install the new speaker and the new cabinet. I'm going to be using a Warehouse G10C per my customer's request. Alright everyone, thanks for watching. Be sure to like this video and subscribe to my channel if you haven't already. And if you'd like to see more, consider subscribing to my Patreon. I'll include a link in the description below. Now sit back and enjoy a demo of this amp by its owner, Taylor Kropp.